Hello, welcome to Zigmatech Learning Hub. I will be your instructor for further mathematics. For this class, we are going to be taking our exercises from the ExamGuide app. If you don't have the application already installed on your device, I will want you to download the app in order to follow along in this class. ExamGuide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WAEC, GCE, KCPE, IJMB, JUPEB, KCPE, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell to be updated on new videos. Ready for today's class? Okay, let's get started. You're welcome once again to today's class. Our topic is matrices, part 1. Let us look at our specific objectives for this lesson. At the end, you are expected to know the definition of a matrix, explain special matrices, solve problems on addition and subtraction of matrices, identify the order of a given matrix, provide solution on multiplication of matrices. Let's go over to the first lesson, which is definition of matrix. Definition of matrix. Matrix is defined as a rectangular array in which numbers, variables, or elements are arranged in rows and columns. In rows and columns. Talking about a row, we have X, Y, P, Q. This is my row. By this way is what? The column. Row. Row 1, row 2, column 1, column 2. So when variables are arranged in rows and columns, we call it what? A matrix. Special matrices, we are going to treat some matrices which seem to be special to us. The first one is what? Symmetric matrix. A matrix is said to be symmetric if the matrix is equal to its transpose. Here comes another grammar here, transpose. From the word symmetric matrix, we got transpose. The transpose of a given matrix is simply changing rows into columns. You now call it what? The transpose of the matrix. Look at, we have X, Y, P, Q. To transpose this matrix, we said this, that is CT, equals changing rows into column, changing rows into column. This is the transpose of a matrix, meaning it is indicated by the symbol C raised to power T or any letter raised to power T, transpose. We have another type of matrix which is called the skew symmetric matrix. I said skew symmetric matrix. When a matrix is skew symmetric in nature, it means the transpose of a matrix or such a matrix is equal to its negative. Given the matrix A, let us look at the transpose of A. The transpose of A, 80, equals 0 minus 2, 3, 2, 0 minus 5, minus 3, 5, 0. Now let us look at the negative of the matrix. if the negative of matrix A is equal to its transpose, it means it is what? Skew symmetric in nature. So let us get the matrix A, which is what? 0. It has been given. Look at it on the system. Now let us get the negative of the transpose. What's the negative? Introduce minus. Minus into 0 is 0. You don't write minus 0. This minus 2. Then this plus 3. Plus 2. This 0. This minus 5. Minus 3. This 5. This 0. Compare it to the original matrix. You can see the negative of the transpose of the matrix was equal to the what? The original matrix itself. Therefore, it is what? Skew symmetric in nature. Square matrix, a matrix with equal number of rows and columns, are known as what? Or is called the square matrix. A matrix with what? Equal number of rows and columns. Okay, we don't need to waste much time here. Diagonal matrix. We're talking about diagonal matrix. A diagonal matrix is when the numbers above or below the principal diagonal in a given matrix, they are all equal 0, but not simultaneously. What do I mean? You can have a matrix. This is 1, 2, 3, 0, 4, 6, 0, 0, 8. See the leading diagonal called the principal diagonal. The numbers above, they are all what? 0. You call it what? Diagonal matrix. The zeros can come down at the down triangle. If this down triangle also form 0 or true, the y here, the upper triangle, are all numbers. It is also called what? Diagonal matrix. But the triangle above or triangle below, 2 of them cannot be 0 at a time. When 2 of them are 0 and the leading diagonal becomes unity, you have another type of matrix which we are going to see here called what? The unit matrix. What is a unit matrix? A unit matrix is a matrix in which the leading principal diagonals are what? 1, unity, apart from the upper and the one above or numbers below, which are what? 0. I repeat, when the leading diagonal of a matrix are all unity, meaning 1, and the values above or below the principal diagonal are all zeros, you call it what? A unit matrix. This is 1, 1, 1, leading diagonal, 0, 0, 0, 0 here, 0 here, 0 here. Can you see it? The upper triangular matrix and the lower triangular matrix, they are all 0. But the leading diagonal, they are all unity, meaning is a unit matrix. Line matrix is a matrix just with 1 row, period. A matrix with 1 row. Column matrix is just a matrix with 1 column. Matrix with 1 column. Now, let us consider addition and subtraction of matrices. Of course, the word at the term addition in maths, you all know. If you have matrix A being equal to this AB, CD, and matrix B being equal to XY, PQ, we know that A plus B equals AB, CD plus XY, PQ, which will give us what? A plus S, B plus Y, C plus P. D plus Q. So that is the solution. In terms of subtraction, you are going to see a minus sign. Let's see question. Given that A is this and B is this, find A plus B. Watching what I just did now, you can see adding that two matrices, we don't have any challenge in doing that. So which is going to give us, this is 2, 4, then 4, 7, plus 5, 4, minus 7, 7, to give us what? 2 plus 5, 4 plus 4, 4 minus 7, 7 plus 7, to give us 7, 8, 3, 14. So A plus B equals what? 7, 8, 3, 14. That is for the addition of matrices. Subtraction of matrices. We're going to subtract B from A. Given the matrices X equals this and Y equals this. Assuming that the A is our X and the B is our Y, it means we are looking for X minus Y, which is A minus B. So X minus Y equals 7 minus 5 minus 2 minus 2, 3 minus 3, 2 minus 2, 0 minus 3, 5 minus 5, 3 minus minus 3, 5 minus 5, 0 minus 0, our solution becomes what? 2 minus 4, 0, 0, 0, minus 3, 0, 6, 0, 0. So this is what we have as our solution for that minus the order of a given matrix. This is another important aspect we need to learn because of multiplication of matrices. If you don't know the order of a given matrix, to multiply becomes a problem. Now let us see how we can determine the order of a given matrix. The order of a given matrix is determined by knowing the number of rows before the column, meaning row multiplied by column equals what? Order of matrix. The word multiplication, let it not confuse you. I'm trying to say considering rows before columns will now determine the order of the matrix. Let's see sample here for order of matrix. If I have A to be this 2, 5, 3, 1, 4, 8, and another matrix B to be 1, 3, 0, 1, 4, 8, 1, 2, 1. If we multiply A and B, what is going to be the order of the matrix? That is the product or the result of multiplying this. What is going to be the nature of the matrix? Remember I said consider the rows. Row 1, row 2, column 1, column 2, column 3. we are considering this. How many rows do we have? We have 2 rows, meaning 2 by, how many columns? 3 columns, meaning 2 by 3. Meaning after multiplication, this matrix is going to lead us into what? 2 by 3 matrix. Now let us think about the multiplication of matrix now. Multiplication of matrix. Multiplication. If you have a matrix A to be A11, A12, A21, A22, against another matrix B, B11, B12, B21, B22. To multiply matrix A times B will imply this: row 1, row 2, column 1, column 2. That is, row 1 times column 1 implies that A11, A12 is going to give us what? B11, B21. That is, when we expand, we are going to have A11 times B11 plus A12 times B21 equals what? Row 1, column 1. Let's consider row 1, column 2. Row 1, column 2 equals A11, A12 against column 2, B12, B22, which is going to give us A11 times B12 plus A12 times B22. So that's the matrix. Now, row 2, column 1 equals what? A12, A21, and A22 against B11, B21, which will give us A21 times B11 plus A22 times B21. Finally, row 2, column 2 will give us what? A21, A22 into B12, B22, which will result to A21 times B12 plus A22 times B22. When you know this, the multiplication of a matrix becomes an easy task or easy nut to crack. So let us multiply 2 by 2, then we multiply 3 by 3 before we can call it over for this period. Now, 2 by 2 multiplication of matrix. If given A equals 1, 0, 0, 1, B equals 1, 2, 3, 4, find A dot B. A dot B, you must label row 1, the first matrix, row 2, column 1, column 1, column 2. That is AB implies that row 1, column 1 equals what? 1, 0, 1, 2. To give us what? 1 times 1 plus 0 times 2 equals 1 plus 0 equals 1. You can see this one, there is a value in this because we are using numbers. But when we are introducing the multiplication, we had alphabet A11, A12, we were receiving 1, 2, 2, 1. So that row 1, column 1 equals 1. Then row 1, column 2 will imply 1, 0, 3, 4, which will give us 1 times 3 plus 0 times 4 to give us 3 plus 0 equals 3. So row 1, column 2 equals 3. Row 2, column 1 equals 0, 1 against 1, 2, which is 0 times 1 plus 1 times 2 to give us 0 plus 2 equals 2. Then row 2, column 2 equals 0, 1, 3, 4, which is 0 times 3 plus 1 times 4 equals 4. Therefore, the matrix AB equals 1, 3, 2, 4. The order of this matrix is what? 2 by 2. So the order of the matrix is 2 by 2. Let us consider 3 by 3, 2 by 2 against 2 by 3. If x equals 1, 2, 2, 3, and y equals 1, 2, 1, 3, 1, 0, 3, x, y equals 1, 2, 2, 1, that is row 1, row 2, column 1, column 2, column 3. So I'll have arrow 1, C1 equals 1 times 2 plus 2 times 1 to give us what? 2 plus 2 equals 4. Then row 1, column 2 equals 1, 2, 1, 0 to give us 1 times 1 plus 2 times 0 equals 1. Row 1, column 3 equals 1, 2, then 3, 3 to give us 1 times 3 plus 2 times 3 equals 3 plus 6 is 9. Now row 2, column 1 imply 2, 3, 2, 1 to give us 2 times 2 plus 3 times 1 equals 4 plus 3, that's 7. Row 2, column 2 implies 2, 3 into 1, 0 to give us 2. Row 2, column 3 will give us 2, 3, 3, 3. That is 6 plus 9 equals 15. So arranging this, the answer here, we're going to have that xy equals the first one 4, 1, 9, 7, 2, and 15. So what is the order of the matrix XY? 2 by 3. Here comes to the end of this class for matrix multiplication. In our next class, we are going to see other levels in matrix where we'll be talking about the multiplication, more part of it, and determinant, minors of matrix, and cofactors. Thank you for participating in today's class. You can practice more questions using the ExamGuide app. The app scores and give a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that make learning fun. It is a must for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel. Hit the notification bell and share the videos to people that will benefit from it. Bye.